Hey YouTube, Kevin Francis, astrophotographer, back at you again. I know last time I was excited about being able to 3D print some threads and actually did some pretty cool things since that last video. And I'm sure you're all wondering, when will it end? When will Kevin stop tinkering with this thing and just move on and start taking a bunch of photos and impressing us with his work? I don't know. I'm constantly looking at things and trying to see how I can improve them. But that's just me. And I figure since you're following this channel, and I really appreciate the 700 plus of you who do or have subscribed to this channel, you've been awesome. A lot of feedback, a lot of good input to a lot of what's been going on. So I just want to say thank you for that. But I'm actually curious to see if you've been doing some of the things that I've done, or something pretty creative on your own with 3D printing or other. Send me your pictures of your setup or what you've done. I'm just curious to see what else is out there that others have taken inspiration from and created on their own. So that being said, let's finish talking about this Orion ST-80 telescope that I've been working on. All right, so there's a couple things that I will talk about today. One of them is Backfocus. That's a major piece to the puzzle that I've had so far that I've had to figure out. The other piece is going to be this lovely webcam and guiding. So I'm sure you want to wait to see how that worked out for me. And in the end, I'm going to let you know whether this actually works, which is the 3D printed components here. So let me start with Backfocus, because that's where my problem has been. It hasn't really been in anything else upstream. Everything here is lined up properly. All of the 3D printed components that are inside of the telescope here are working fine, and they've been working fine for weeks, and they're all made out of PLA. Temperature changes and fluctuations haven't really affected the performance up through the field flattener, which I'll also talk about today, by the way. So they've been great, but where I've had the struggle is that telltale pattern around the outer edge of the photo that says that my back focus isn't right. So taking a look at what ZWO posted on their manual for this particular camera, or cameras like it, I've got to have 55 millimeters of back focus in order for this to focus properly. And then for the Hotech field flattener, I also checked that out. It's also 55 millimeters, so it's a marriage made in heaven. So to make this work, I really need to make sure that I get that 55 millimeters. And where I struggled was the spacers that I did have, they continuously would ride into the M48 threaded spacing of the filter. So it was always moving back and forth with temperature change or other things, me moving it or whatever, touching it, however the case may be. And so I tried 3D printing this app to put on there to keep it from sliding into this filter drawer. So that worked to some degree, and that was part of the previous videos that we saw. And so I decided, since I can print threads, I'm just going to print the right size spacer so that it sits flush against this filter and it sits flush against the field flattener. And that's what I have here. It's perfectly 16.5 millimeters, well, close enough. Maybe 16.52 or something like that, based on my 3D printer's capabilities. But that's working really well. Not a lot of changes going on there. And then everything else is the filter, the spacer that comes with the camera, and the 6.5 millimeters of additional space all the way down to the sensor. So I have 55 millimeters here per the math. This is now printed out of PETG, and the reason I did PETG is it's far more resistant to temperature change than PLA. So I was explaining earlier, the other components inside of this telescope that I printed out of PLA are working beautifully, even with the temperature changes that have occurred. But I'm less likely to go with that long term with this spacer. So that's why I printed out a PETG. So one other thing is I also had a spacer, or not a spacer, but a threaded connector here between the telescope and the field flattener that was very, very large. As a matter of fact, take a look at this dimension. So I've shortened that by a lot to about 4 millimeters by, again, 3D printing another spacer adapter, which is, you cannot see in here, but it's right inside of the field flattener itself. So that field flattener is M48, and the telescope itself is M42. So that's all that spacer is just to fill that gap, and it's been holding really well. It's also made out of PETG. I've not had any problems with it sagging or falling or even threatening to come off. I also took the opportunity to 3D print a holder for this webcam. So if you remember from my very, very first video, that's a ways back, I created a holder for the mount that I can put this USB camera onto, and I was able to use it for polar alignment. Well, now that my telescope mount is in the same spot every day, all the time, just covered or in use, I don't use this very often. So I thought, why not? PhD2 allows us to use a USB camera. Just install PhD2, put this right here up top, got everything focused, calibrated it, and I'm now guiding. This has actually allowed me to do a couple of things. One, in evaluation of this back focus part of my problems, the stability that this guiding has given me has allowed me to actually see the true effect of what is happening with back focus. So I've been really impressed at its ability to work. I didn't know it would be that simple or that easy, and to be able to repurpose this to this role saved me a lot of money. Didn't have to buy a scope or a guide camera to do that work. It's just working. You want to know, did this work? And the best way for me to show you is to show you some pictures, because guess what? It did. It did the job. So the shifting that I've had and the tilting that I've had, well taken care of, and now the back focus is right where it needs to be. Now, and don't forget, go ahead and send me anything that you have, that you've done, that you've been creative with in terms of 3D printing, or any other ideas you have for your own telescope. I'm very much interested in that. Don't forget, the sky is only the limit when your mind is unwilling to fly, so go beyond. Thank you all. Kevin Francis, astrophotographer. Enjoy the photos.